So let me start by telling you guys that I absolutely am hating technology right now, and I'm pretty good at it, but it's failing me. Okay, so I'm gonna preface with that because this is now like my 75th time trying to make a video for you guys. Transformations, that's what we've been working on. That's what we've been doing to functions where we've been applying inside change and outside change. However, now we are going to take those transformations and we're going to move them along. We're going to now apply them to the parent function. The parent function is your new vocabulary, right? We briefly talked about it, but it just means the original function, okay? So keep in mind, it means exactly how it says. It's before, right? Your parent is your before your DNA gets combined to you. That's the same thing. It's before any transformation is applied. With parent functions, what we are going to be doing is talking about the most common ones in Algebra 2. We're not going to get to all the functions that we normally get to just because of time. We are going to stick to the common ones like x, linear, right? X squared, quadratic, x cubed, cubic. Excuse me. Those are common ones that we use any power. Absolute value of x. Radical x, we have not gotten to yet. We will get to those. And then the rationals, 1 over x. Rationals are my favorite because they are about money. Then there is inside change, which applies to the x value, and outside change, which applies to the y value. Again, it's the same type of change throughout the whole year, okay? It's just applied differently. So now we're going to look at some examples of how inside change and outside change is applied on our functions. So x plus 2 inside the parentheses squared, and then x squared plus 2, now that's outside or no parentheses. You can also do multiplication. So you can put 2 times x, close those parentheses, cubed, or you can just do 2x cubed, where now it's outside of parentheses. Absolute value sign acts as a parentheses, so you don't need a separate parentheses. You just need to put your transformation inside the absolute value, x minus 2, or outside the absolute value x minus 2. Radical also acts as its own parentheses. They're both grouping symbols. So inside is under the radical, outside is outside the radical. Numerator and denominator, they're their own grouping types. If you don't remember that from fractions. So when you want to write inside change, you just have to write that inside change underneath in that denominator because it's applied to the x value. When you want outside change, you write that fraction and it's outside of the fraction. So that's outside change, okay? You can screenshot this, but these are the basic parent functions. We are going to then take this and we're going to apply it to our packet. Page 17 in our packet is the next page we are going to work on. Everything else in this packet after today you should be able to do. The first 2 paragraphs are mathematical terms and that you would use on the graph to show the transformation. I'm most likely not going to make you memorize those. However, they might be bonus questions, right? So make sure you read through them. G of x in this is the transformation function. Notice there are lots of transformations. There's not just inside or outside. There is an inside change and there are 3 outside changes. In order for you to break down those changes, you have to write the story like we did in the past when solving, right? However, it's a little bit different this time because now you're writing that story. Inside change applies to x, outside change applies to y because this is a function, not an equation, okay? So it's a little bit different. When you begin to write that story, you're going to look at the little details. You're going to write those steps out. So if you see, the steps are written out for you right here, right? The first step, though, add to the x, translate. Look at the equation where it says x minus 2. The reason why we change that to addition is because for inside change, you do the opposite sign. We talked about that briefly. However, I want you to remember that. Star it, write it down, highlight it. Inside change is the opposite sign. We will get to the y and the formula for that. I don't want to give it to you now. It's just too much at once. All right, so write it down. Inside change is the opposite sign. So if I go back up to my steps, add 2 to the x translation, then I multiply y by 3. You multiply y by 3 because it's outside change. Change the sign because there's a negative. And remember, whenever we were applying a negative, we change the sign. The last step is we add 1 to y. Again, it's outside change. The parent function is the absolute value function. Okay, that's the original function before any transformations. We go down to the bottom. F of x is done out for you where the points, right? If you were to plot those points, you would get the absolute value function. Then you have to apply the transformations to get your g of x. So we're going to take them one at a time and apply them to the original points given. Okay? Don't forget, reflect is the same thing as changing the sign. Okay? You're reflecting it on the graph. Step 1, add 2 to x. We're not doing anything to the y, so we're going to just write down and record those values. Then we're going to go and apply the change to the x value. They did the first two. Negative 4 plus 2 is negative 2. Negative 2 plus 2 is 0. And so we're going to work on 0 plus 2 is 2. 2 plus 2 is 4. And the last one, 4 plus 2 is 6. Okay, so if we move on to the next step, right, we're just going to apply one step at a time. Step 2, we're multiplying y by 3. So we're going to take our x values and we're going to record them because we're not doing anything to them for this step. We're going to go back now to our y values and we're going to multiply them by 3. They did the first two for you. So we continue. 0 times 3 is 0. 2 times 3 is 6. 4 times 3 is 12. Okay? So hopefully you're noticing the pattern by now. We're going to move on to the next step, reflect. We're not doing anything to the x value, so we're going to record those values. Then we're going to move on to the y, and we're going to reflect them, which means we're just going to change their sign. Okay, so they did the first two again, right? The 12 becomes a negative 12. The 6 becomes a negative 6. So 0 doesn't have a sign. 6 becomes a negative 6. And 12 becomes a negative 12. The last step is you're going to add 1 to y. So again, we're not doing anything to x. So we're going to record those x values. They did 3 of them this time for you. So we only have to do the last 2. So if we add 1, we'll get negative 5 and negative 11. So now we have our g of x function. We can take and plot these points next to the original f of x points, and you can see the changes in the graph. However, I'm not going to make you plot points or graph them out by hand. We talked about this. Because we're doing online, use your technology. Go to Desmos.com and use Desmos. Log in. Make sure when you log in, you use your school email. This way, it saves to your school account. It's easy accessible to Google Classroom. Okay? Some key features. The little box with the arrow lets you download or export your graph. Copy the link, export image. I would say export image because then you can put it into your documents. You can save all your graphs. You just name them whatever you want to name them. You can recall pictures. The plus sign, you could take the plus sign and add a table. So for our last assignment, we could go ahead and put those tables in and see them plotted on Desmos, right? You can also go in and add functions. You can put in as many functions as you want. Just keep hitting the enter button. I've done like 20 on one graph, so I know you can do a lot. You can also hit the plus sign to add an image. We're going to use absolute value because that was the one we were working with, okay? So this is the parent function. If you want to change the color, you just hit the settings button and you click on the color. Just that easy, okay? You hit enter and now you can put a different function. We're going to do some outside change, 3 absolute value of x. And now you can see that it's green. The new function is there. Sorry. The transformation is condensing it closer. You can change the settings. We can make our x-axis from -5 to 5. We can count by 1. Click back on the graph and now you have a different view. It doesn't really change the graph itself. It's just changing the view of the graph. We're going to put in a third function. It automatically gives it a third color. More outside change, absolute value of x -2. If we wanted to, right, you can delete the view of the green function without deleting the function. Just tap on the color. If you double click on intersecting points, it will give them already. If you want to see other points, you just drag your cursor across the function and it gives you any point. You zoom in and out by pinching like you would do a picture. Okay, on your packet now, you should be able to finish the last few pages, right? The pages above, use Desmos to play with the functions, answer the questions about the functions, draw a sketch. Page 18, which is going to be due on Friday, they give you 3 functions, 3 transformations. You're going to apply the steps. They wrote the steps out for you for the first 2. For the third one, you have to write the steps. However, make sure you pay close attention to the first 2. Reflection and don't reflect. Reflect comes when there's a negative. Don't reflect comes when it's positive. So for the third one, you have to decide if it reflects or it doesn't reflect. You cannot skip that step. You decide it based on whether that outside value is positive or negative. Okay? If you have questions, please ask them. This better work because this is at least my 10th time. Okay? Bye.